welcome to our training session on the iBECOME mobility services of car sharing and EV charging optimization, and how with these two services is possible to implement commuting optimization for the employees of a facility. ENER.GI's services are delivered as third-party additional services and have as one of their goals the demonstration of the possibility to integrate in iBECOME services developed on external servers. Car sharing and EV charging optimization services are deployed through the connection with Schneider's enterprise server to act on the EV charger and through the connection with iScan to acquire information on the cost of energy. The core hardware device that enables the remote control of the vehicle is ENER.GI's BB01 that allows the key dematerialization, vehicle position acknowledgement, and vehicle status update. The mobility services of car sharing and EV charging optimization rely on ENER.GI's server and the hardware device BB01 installed in an electrical vehicle. In the iBECOME project, the services implement the commuting optimization feature that aims at promoting vehicle sharing for the employees, while assuring CO2 emission reduction and charging optimization. Both services are delivered to the final user through a dashboard and a mobile app. The car sharing service is intended to be delivered to the employees of a facility. The facility provides one or more company cars for the employees to be used for site visits or daily commute. The car sharing service enables the booking of the vehicle, allowing the possibility to request the sharing if the vehicle is already booked in the needed time slot. The commuting optimization algorithm works by comparing the route booked and the route requested for sharing, allowing the car sharing only if the route that connects the two users and their destination sums up to a total of kilometers that is lower than the sum of the two routes separately. The EV charger optimization service is strictly related to the car sharing service, as it can optimize the charging process with respect to the car sharing booking in order to be always provided with a minimum level of charge that allows the user to travel the route that is booked. The EV charging optimization service is also interconnected with the building, since in its hardware requirements for the implementation there is the installation of a charging station in the premises of the facility. The EV charger service reads data from the energy consumption and energy costs or energy production from the building and forces the charging process or modulates the power delivered only when the energy is cheaper. The mobile app and the dedicated dashboard developed in the iBECOME project intend to give to the building owner or facility managers that need to manage a vehicle fleet a simple tool to be able to track the use of the vehicle, promote commuted traveling, and acknowledge the CO2 reduction that this type of mobility can achieve. The commuting optimization is achieved with the optimal use of the service and the features of the app. The app has been tailored to respond to the needs of the employees of a facility like ASP Venzone, thanks to the survey that was circulated in one of the site visits. ASP Venzone was the only pilot in the iBECOME project to have these third-party mobility-related services implemented. That the outcome shown in this video is strictly related to its use case. While the car sharing service is mainly delivered through the mobile app, the EV charging optimization can be activated through the dashboard of the service. Both services rely on user interaction for their correct functioning. The commuting optimization, above all, can be fully deployed only if the app users are willing to adapt their habits to contribute to reduce their carbon footprint and embrace green mobility. This shift of paradigm, by having the employees to actively contribute to reach the targets, has been investigated in iBECOME and has had an encouraging outcome.
Now we will see how does the mobile app work. On the main page, the user is shown a map centered on its position. In this case, the user position is the same as the vehicle that is identified by a red pin. The user can now search its point of interest on the search bar and add a pin by clicking on Add the Place. To add a reservation, the user has to go to the calendar page where all the reservations are made visible by a red or green dot. To book the vehicle, the user has to select the day, the time of the reservation, and the start and destination location for the trip. To see the reservation details, the user can then click on the red dot. From this window, the user can also edit the reservation or add another reservation for the day. For example, let's add another reservation for the return trip from ASP Venzone to Tavagnacco. By clicking on the red dot, we can see both reservations and their details. Now, the user has to wait for its reservation time window to start. Only at that point the virtual key fob will be enabled, as well as the dematerialization of the key. During the reservation time window, the user will be able to see on the main page the new buttons for starting the trip and open the navigation directions. To simulate the commuting optimization, we need to send a sharing request from another user profile. Let's log in Luigi Bianchi and send the request. The user will see a red dot on the calendar. When clicking on it, the detail of Mario Rossi's booking will be available, as well as the option to send a sharing request. Let's select the reservation from Tavagnacco to Venzone. Now Luigi has to add its start and destination place to enable the calculation of the commuting optimization algorithm. If the commuting optimization algorithm gives a positive outcome, the app sends a sharing request from Luigi Bianchi to Mario Rossi. Now, the request is sent in the messaging page of the app. We can read the message that underlines the booking details and the time. Now, let's log in again in Mario Rossi's profile to see how the commuting optimization request can be accepted. Mario Rossi will see a notification in the messaging page and read the message from Luigi Bianchi. The app allows the user to accept or decline the sharing request by simply selecting yes or no and automatically sending a message as a reply. Now, Mario Rossi can start the trip.
After logging in with the credential, we will be able to see how to navigate the dashboard. The dashboard offers in its main page a map that is centered on the building's location for the fleet manager to be able to see the localization of the vehicles when they are near the facility. In the case of the deployment for the iBECOME ISP Venzone pilot, only one vehicle has been equipped. At the moment, the vehicle is not in the proximity of the ISP Venzone facility, but it can be seen down here. The main page also shows the vehicle status, the charger status, and the statistics on the commuting optimization. The status of the vehicle lists the number of vehicles that are online and are able to communicate, allowing the administrator to be aware of eventual faults. It also shows if a vehicle has a state of charge that is below 30%. And if there are any vehicles outside the vicinity of the building. The status of the charger in an analog way shows the chargers that are online. For SP Venzone, only one charger has been installed, and so we can see only one charger online. When the information on the status of the vehicle is retrieved from ENER.GI's hardware device mounted on the vehicle, the status of the charger is an information made available and retrieved from enterprise server. On the main page, the administrator or the building manager can also see the statistics on the CO2 reduction achieved with the commuting optimization, in particular the total kilograms of CO2 that have been reduced and the total kilometers that the commuting optimization has saved. The kilometer reduction is calculated with the commuting optimization algorithm that compares the travel option of the users that request the sharing and initiates the commuting optimization only if there is an effective reduction. In the vehicles page, the summary for the number of trips, the commuting optimization, and the kilometer performed by the vehicle are visible. The results are differentiated by vehicles. In a scenario where there is more than one vehicle, the fleet manager can see the details of each vehicle in terms of trips and commuting optimization. For the iBECOME implementation, only one vehicle has been equipped, and so we can see the vehicle here. In the page with the details of the chargers, the manager can select with which one of the energy cost profiles want to perform the charging optimization. This is the energy cost profile that simulates the production of energy from a renewable source, that is in this case photovoltaic panels. The second profile that has been selected is the energy bands profile that follows the definition of the energy bands cost profile defined by the energy service provider. Lastly, the fixed cost profile shows an energy cost profile that has a constant value, so that each hour of the day the cost of energy remains the same. The building manager can so select the energy cost profile, and from this page it can enable the EV charging optimization. From this selection here, the charger can be enabled as automatic, so following the energy cost profiles, can always be enabled, or it can be disabled. In this page, the building manager can also have visibility of the building power usage and the charger power usage only if a vehicle is effectively connected to the EV charger. The building manager can select an energy price threshold that represents the maximum cost that the building manager is willing to pay to perform the EV charger. The building manager can also select the power limit, so it can modulate the power that is delivered by the EV charger. It can also select a minimum level of charge that the vehicle has to reach by the time that is booked. On the page dedicated to the users, the manager can activate users to grant access to the mobile app and see the statistics of each user in terms of kilograms of CO2 saved. As an example, we can see the user Bianchi Luigi and all its statistics. Also Mario Rossi.
Thank you for joining me in this brief exploration of the third-party services of car sharing and EV charging optimization developed by ENER.GI for the iBECOME project.